Welcome back to our Computer Systems unit. Today we will be looking at the computer structure. As always, we have some learning intentions. These are as follows. We will learn the purpose of the central processing unit and its structure, including the control unit, the arithmetic and logic unit, and the registers. We will learn the purpose of random access memory and how data is stored. We'll learn how the CPU, memory, and input-output devices are connected together using buses, and we'll learn how the computer programs are translated into machine code for the CPU to execute. Today our success criteria will be as follows. I will be able to describe the purpose of the central processing unit and its structure, including the control unit, the arithmetic and logic unit, and the registers. I will be able to describe the purpose of random access memory and how data is stored using random access memory. I will be able to describe how the CPU, memory, input and output devices are connected together using buses. And I will be able to describe how the computer programs are translated into machine code for the CPU to execute. Here is a definition to start us off. Translator. A translator is a computer program used to convert high-level language to machine code. There are two kinds of translator, interpreter and compiler. We'll learn about these later in the lesson. Firstly, let's talk about the central processing unit. Let's look at its purpose and its structure. Central processing unit, sometimes referred to as the CPU, is responsible for all the executing of instructions found within a computer program. It can be thought of as the brains of the computer, and it can execute many millions of instructions per second. There are three main components within the CPU: the control unit, the arithmetic and logic unit, and the registers. Let's look at the CPU structure in a little more detail, starting with the control unit. The control unit, or the CU, directs and synchronises all operations of the processor and manages the system clock, which determines how frequently the CPU executes instructions. The clock speed is measured in Hertz, and most modern CPUs operate in the gigahertz range. The CPU is responsible for the fetching and executing of all instructions within the processor. It's also responsible for initiating memory read and memory write operations to and from main memory. The second part of the processor is the arithmetic and logic unit. This is the part of the processor which handles all the calculations and logical operations, such as calculations involving arithmetic operators, such as addition, subtraction, multiplication and division. All calculation involving comparators, such as less than, greater than, less than or equal to, greater than or equal to, or equal to. And finally, all the logical operations using logical operators such as and, or, and not. And finally, let's look at the registers. The registers are lots of temporary storage locations in the CPU. They are physically on the same chip. The registers are used to store data that is currently in use, instructions in execution or to be executed next, memory addresses for data and instructions that must be fetched from memory, or just a variety of different types of data that are stored within the registers. Let's now talk about memory. One type of memory in a computer is called random access memory, or RAM. And RAM is used to store all the programs that are currently running on the computer system. So for example, perhaps Microsoft PowerPoint or Microsoft Word. It also stores the operating system, like Windows, when the computer is turned on. It also stores information related to any processes that are being executed. RAM is cleared when the system is turned off. RAM can be thought of as a working area. Anything that is being used on the computer system will be stored in RAM at that point. RAM is divided into lots and lots of storage locations. Each location has its own unique address and can store a certain amount of data. Current desktop and laptop computers will contain between 8 to 16 gigabytes of RAM. Higher values of RAM increases the number of programs, including associated data, that may be opened at once. Let's now talk about how we can connect our computer components, such as the CPU and RAM, together with the input and output devices that we normally use on a computer system. How do these things communicate together? Well, they communicate using something called buses. And buses are electronic connections or wires that connect the CPU and different parts of a computer system, such as the input-output and RAM, together. There are three important buses: the address bus, the data bus, and the control bus. For National 5 Computing Science, you need only understand what the address bus and data bus do. However, we will discuss the control bus as all three buses work together to carry out any operation. The data bus. This carries data between the processor, memory, and input-output. It is bidirectional, meaning that data can flow both ways. The data bus is the only bus that carries the data and instructions used when running programs. The second bus is the address bus. The address bus holds the address of the memory location in RAM that the processor wants to read from or write to. It is a unidirectional bus, which means it's one way. The processor sends the address or addresses to main memory and input-output. And finally, the control bus, which at this moment in time is unexaminable at National 5 level. But the control bus can be thought of as a series of different lines or wires, each having a different function, such as a read line, which is used to execute a read from memory to the processor, a write line, which is used to execute a write from the processor to a memory location, an interrupt line used to signal that a program or device wants the CPU's attention. There are many other lines in the control bus. Each of these three buses work together. Data is placed on the data bus. The address bus has the address of the memory location placed on it. And then the control bus will execute one of its series of lines. Now let's talk about translators. Central processing units follow instructions and operate on data which is represented in binary or machine code. Machine code is the language that a computer system understands. It is made up of ones and zeros. Machine code is very difficult for humans to understand though, so computer programs are mostly written by humans in high-level languages instead. High-level languages are programming languages which use English words. They are close to natural language, but are not actually English. Programs written in high-level languages must be translated into machine code for the CPU to understand the instructions. We use two main types of translator to do this: an interpreter and a compiler. Interpreters translate and execute each line of high-level language into machine code in turn, one line at a time. As we can see from the animation. Interpreters will stop translation and execution if they encounter an error. They will then notify the programmer of where the error was found. The interpreter runs throughout the entire translation and execution process. It resides in main memory. The advantages of using an interpreter mean that errors are highlighted to the user immediately, making debugging code easier. Interpreters can run incomplete code or code under development also. They are very good for development environments. Interpreters also have some disadvantages. The interpreter must be present every time the code is run. That means it resides in active memory or RAM. If the code is repeated, like in a loop, the code is translated and run many times. Applications will take longer to run as they have to be translated each time. The alternative to an interpreter is a compiler. Compilers translate high-level code into object code or machine code. The object code is held in a new file and does not require the use of a translator software to run. The compiler translates each line of code and adds the translated line to the object code. Only when the translation is complete can the code be run. If no errors are found, the source code does not need to be translated again. When the source code has been translated, the compiler is never needed again. Compiled applications are portable, which means they can be run in different computers. Applications run fast as the translator does not need to run at the same time. However, there are some disadvantages. If any syntax errors are present, the program code will not run. The errors can be more difficult to correct as they may not be visible until translation finishes. And the entire program must be translated before it may be run. Thank you for joining us in this lesson. For more lessons, please visit our faculty YouTube channel, Grive High Business and Computing Science. Please remember to share and subscribe.